Have you ever poured weeks of exhausting effort into a goal, only to end up exactly where you started? When that happens, the problem usually isn't a lack of willpower. A flawed system is to blame. To build a process that actually works, you have to design an automatic, frictionless routine. We can construct this by following a 5-part mental map. First, we have to recognize the difference between the map and the territory. A map is simply an explanation or a model of reality. Suppose you want to navigate through Chicago, but you were accidentally handed a street map of Detroit. You can double your driving speed or try to maintain a positive attitude, but neither action will help you reach your destination. You are working from an inaccurate blueprint. A reliable system requires an accurate understanding of the reality you are operating in. Quick fixes and raw effort cannot overcome a bad map. The fog behavior model breaks down how systems produce action. Behavior happens when 3 specific variables converge at the exact same moment: motivation, ability, and a prompt. This graph maps motivation against ability. If a task is hard, you need massive motivation to cross the action line, but motivation is unreliable. A well-designed system shifts tasks right, making actions so easy they require almost zero motivation when prompted. When you engineer your environment so that your capability matches the required drive, a simple spark is all it takes to keep the machine moving. Once a system is running, it will inevitably hit snags. The common instinct is to try and upgrade every single component at once to increase speed, but this ignores the single slowest point in the chain. On a factory assembly line, a single slow robotic arm causes inventory to pile up. The entire operation only moves as fast as this sluggish component. To fix the output, you wouldn't upgrade the fast machines, you'd focus entirely on the bottleneck. Diagnosing and improving that single point of friction is the only effective way to increase the velocity of the whole machine. Even a smooth operation will stall if you feed it too much material. We often assume that doing more work automatically yields better results. This text outlines a core philosophy of essentialism. A tiny fraction of our efforts produces the vast majority of our desired outcomes, meaning most tasks are trivial. A highly efficient system prevents useless work from entering the pipeline in the first place. You must apply tough criteria to ruthlessly filter out the noise. By cutting away the non-essential, you protect your limited resources and accelerate the execution of what actually matters. No one builds a flawless system on their first attempt. Start with minimal viable progress, the simplest working version, and get it running. Once moving, look for tiny adjustments. 1% improvements seem invisible daily, but stacked over months, they drastically compound. These steady, microscopic tweaks are the actual mechanism for building a system that eventually runs itself. To review, we secure an accurate map, we balance motivation, ability, and prompts, we identify the slowest bottleneck, we eliminate the non-essential, and apply constant minimal improvements. Enduring success doesn't come from pushing yourself to the brink of exhaustion. It comes from stepping back and engineering a smarter system.